Alright, so this is problem 19 in the exam 1 review set for ES 110 statics. So in this problem, we have a force F away from a point P, and we want to find the moment that F causes about P. So this is a 3D problem, and with 3D problems and when we're dealing with moments and weird directions and weird spaces, it's best to use a matrix method to deal with all of those things and keep them in order. So remember, the definition of a moment is, in this case, the moment about P is equal to, we have the force is applied at A, and the point we want to take the moment about is P. So the moment about P is equal to the position vector of A with respect to P cross product with F. And remember, those are two vectors. And when we take the cross products, we remember that we get a vector back. And in terms of a determinant, we can also write this as the determinant of this matrix, IJK, RAPX, RAPY, RAPZ, FX, FY, FZ. And it's the determinant of that matrix. So the first step of this problem is really just finding what those vectors are. The problem gave us actually what the components of F are, so we already know Fx, Fy, Fz. We're good there. We really just have to find RAPX, RAPY, RAPZ. And we can just do that by inspection. So we look, since we're finding A with respect to P, we want to go from P to A. So in the x direction, to go from P to A, we have to travel plus 4 meters. So we write 4I. In the y direction, we have to travel plus 4 meters. So we write plus 4J. And in the z direction, we have to travel down 2 meters, minus 2J. So now that we know Fx, Fy, Fz, and then the position vector, we are all ready to take the moment using the determinant of that matrix. So we'll write some more space down here. We'll have MP is equal to IJK, and we'll start plugging in our numbers. So 4, 4, and -2, and 40, 60, and -20. I'm not writing units to save space, although you should write your units always. But as long as we know we're working with newtons and meters, at the end we will get Newton meters. Okay, so remember our trick for 3D or 3x3 determinants. When we want to find the determinant of a matrix like this, we multiply I times the determinant of that matrix. So we have I 4, -2, 60, -20, minus J times the determinant of this matrix. So 4, -2, 40, -20, plus K times the determinant of that matrix. So 4, 4, 40, 60. And remember, when we take the determinant of a 2x2 matrix, it's pretty easy to remember and easy to do. We're multiplying these two numbers minus multiplying these two numbers. So we have 4 times -20, which is -80, minus the product of these two. So we have 60 times -2 is -120, minus -120 is plus 120. I minus J, we have 4 times -20 is -80. 40 times -2 is -80, but we're subtracting -80, so we're going to add 80. And that's all multiplied by the J vector. And then K 4 times 60 is 240 minus 40 times 4, which is 160. Okay. And if we do that arithmetic, we see that this becomes 40i minus, this just cancels out to 0, plus 0j. 240 minus 160, that is 80, plus 80. Okay. So this is our answer. And again, remember, we are working with Newton meters. And this is a vector. That's important to remember as well. You cannot add these together because these are 3 different directions, and this is a vector. This is not a scalar number. This is a moment.